This paper proposed TapNet for off-screen tap interaction. TapNet is an one model for all solutions that jointly learn from data across devices and perform multiple tap-related tasks. TapNet can recognize tapping from front, back, sides, and more. Side tap are indicated by blue, front tap by red, and back tap by green. Heat map here without dots indicate tapping with fingerpad, and those with dots are fingernail tapping. This tap recognition is produced by a neural network that understands the IMU signals. It can also recognize non-tap signals such as grip holding, phone shakings, and on-table vibrations, etc. Here we can see how sensitive the back tap recognition can be. You don't even need to tap hard with long finger travel distance. And it can also recognize the shaking motion of tap release. Please take a look at the accuracy of tap location and direction from these demonstrations. According to our evaluation, the tap location accuracy is roughly 1/10 of the screen diagonal. So what can TapNet be used for? The one-handed interaction is an obvious choice and it happens everywhere. For example, when you are taking the subway, walking on the street, or even biking. Not safe though. Or when you are holding the camera in the other hand like this, or lying on bed, as always. Assisted tap use back tap and tilting for one-handed interaction. On the right, you can see we can use tilting to select a target gesture from any initial orientation. And here is a quick demo. We can use double tap to invoke this one-handed mode, tilt to control the target gestures, including scroll up, scroll down, go back, and switch app. Once the target gesture is selected, you can use single back tap to confirm the selection. In this way, users can perform most of the commonly used gestures in the one-handed mode. In other words, no more worries when you are browsing news feeds, YouTube, Facebook, Twitter when you are lying on bed. In particular, for interaction that require a lot of scrolling, you don't even need to tilt a lot. In most of the cases, you only need to hold the phone in a natural way and perform a single back tap, and then back tap. And this will also be useful to check notification and get your overview. But how about the two-handed interaction paradigm? Talkback would be an interesting feature. There are so many navigation gestures that a new talkback user need to learn. In contrast, we propose to use double tap to easily get into the talkback mode and lifting the exploration touch finger to leave the talkback mode.
Settings, calculator.
Just like this, double tap to get in and lifting the finger to get out.
Calculator.
Here is a quick demonstration. The blue eye icon indicates we have used
Photos,
double tap to get into the talkback mode.
Tap visualizer.
Lifting the exploration touch finger from the screen will make the icon disappear.
Get the latest information. When will I receive my US coronavirus stimulus check? If you missed out on Ada Awkward Peak, you may be in luck Tuesday night.
Without seeing the blue icon, we can just navigate the system in the common way.
CNN sends Trump campaign cease and restaurant closings in the San Francisco. Solo truckers struggle to get rolling with stimulus fund.
This may also simplify how we type in the talkback mode.
H E R K L O X space E W E I O U T R T K L H E D.
Not yet. There are many more new possibilities enabled by TapNet. For example, we can interact with the wallpaper using off-screen tapping. Here, back tap is used to switch a flashcard, and side tap is used to switch a set of them. More importantly, this can work even when the screen is locked. It thus encourages users to make use of the bits of the time to perform their favorite interaction at the moment they take out the phone from the pocket. In this example, we can detect front tap from the motion. It works even though we are wearing gloves or using a non-capacitive pen. Such recognition result can be used to correct the capacitive sensing. For example, in the case when there are water drops on the screen that affects the sensing reliability. Please refer to our paper for more details.